everyone, in this video we're going to look into the properties of logarithms, and this is the second part. I will put the link of the first part in the description box below. So let's take this first property right here. Log of 1 to the base b is equal to, so we need to determine what is this equal to, and that would be the first property. So the first thing that we're going to do here is we let this whole expression equal to x. Okay, so once we let this x, we can actually change this into its equivalent exponential form. And that's gonna be b to the power x is equal to 1. So what I did was I changed the logarithmic form to its equivalent exponential form. So we're going to determine what value of x should we have in order that we can have a 1. So our x will be equal to 0, because anything raised to the power 0 would be equal to 1. So it doesn't matter what this value of b is, or whatever this base is, whatever that value is, it doesn't really matter, because anything raised to the power 0 is equal to 1. So this statement that we have here is that log of 1 to the base b is always equal to 0. And this is our first property. So then we can go ahead and look at these examples right here. We're supposed to evaluate. So log of x to the base 3 is equal to 0. So then it means that our x here is actually equal to 1. Because as you can see, the base is 3, which the base doesn't really matter. And then we have a 0 as an exponent, so that should be equal to 1. So others are going to say, how do we set this up to better understand this? So we can actually change this to its equivalent exponential form. 3 to the 0 is equal to x. So that means our x is equal to 1, and that's how we got the 1 right there. Now, looking at the second example right here, so then we're supposed to solve for y, since the ones inside the parentheses is 1. So then this means that our y is 0. So then we can go ahead and change this to its equivalent exponential form. 5 to the y is equal to 1. So what should be the exponent of 5 in such a way that we get a 1? So y is equal to 0, and that's how we got the 0 right here. Now let's move on to the second property of logarithm. So first we have log of b to the base b. So what are we going to do here is we're going to use the change of base formula. Once we use the change of base formula, this notation that we have here, or this expression that we have here, would come out log of b over log of b. And so log of b over log of b is actually equal to 1. So pretty much this log of b to the base b is actually equal to 1. And this is the second property. I'm going to put this inside a red box. So that's the second property right there. At this time, I would encourage you to pause this video and try these two problems out on your own. You solve for y. And if you're done, unpause it and check your answer. Okay, so we go over the problem here. So first, this y that we have here is the same thing as the base, which is 7. And we can actually rewrite this in exponential form. So that would be 7 raised to the power 1 is equal to y. So then that gives us y is equal to 7. And that's how we got the 7. The same thing for this. So we wanted to determine what should be our exponent to 9. So that would be 9 to the power y is equal to 9. So then that means our y should be equal to 1. So our y here should be equal to 1. So this matches up. Both base are the same, so 7 and 7, because the whole expression is equal to 1. And then since both bases are the same, so this is equal to 1 right here. Did you get the same answers as this? Good. Perfect. Now let's move on to the third property right here. So we have log of b to the power m to the base b. So what is this equivalent to? So the first thing that we're going to do here is, since we have an exponent, we're going to use the power property. Okay, using the power property of a logarithm, power property means that whatever the exponent is, we put it in front. So this becomes m log of b to the base b. That's the power property. We are going to make the exponent as a coefficient of the whole log expression. Now, what are we going to do next is we're going to use the change of base formula. Okay, using the change of base, we can rewrite this as m times, this one is log of b over log of b. So we can change this to two logs that are put on top of each other. So whatever is in here, that would be over to the log of the base right here. So then we can go ahead and say that this log of b over log of b is 1. So that is m times 1, or pretty much is equal to m. So this log of b to the power m to the base b is actually equal to m. And this is the third property. So I'm going to put that inside a red box. And so we go over the problem here. So both bases are the same. And then we have m as an exponent. Remember, this is the x here will be equal to the m. So both m's right there. So this x would be equal to 3. And then this one right here, since both exponents are equal to m, so both are m's. So then we go ahead and say that these two would also be the same, both b's. So that has to be 7. Okay, so this is the third property. Now let's move on to the fourth property. Log of 1 over a to the base b. So what is this equal to? So the first thing that we are going to do here is we're going to use the property of exponent. Okay, we want the a on top of the fraction, so we can go ahead and rewrite this as log of, that's gonna be a to the negative 1 over b. So this 1 over a is actually equal to a to the negative 1. And then from here, we are going to use the power property. So using the power property, whatever is the exponent, that will come out as the coefficient of the whole log expression. So we can rewrite this as negative 1 times log of a to the base b. So I just placed the negative 1 in front of the log. So pretty much negative 1 multiplied to this whole expression right here, that would come out a negative log of a to the base b. So this expression right here can be rewritten as negative log of a to the base b. And this is our fourth property. So that's the fourth property right there. So we go over this problem right here. So then what is this equal to? So we can go ahead and use the steps that we did right here. So we're going to use the property of exponent. So this can be rewritten as log of 4 to the negative 1 to the base 3. And since the negative 1 is an exponent, we can write it in front. Negative 1 times the whole log expression. That's going to be log of 4 to the base 3. And so negative 1 multiplied to this expression would come out negative log of 4 to the base 3. So this is how we evaluate this expression up there. Now let's move on to the fifth property. So this is the fifth property right here. That's log of a to the base 1 over b. So we're going to determine what is that equal to. So first, we are going to use the property of exponent, because this one is 1 over b. So we're going to use the property of exponent. So using the property of exponent, we can rewrite this as log of a to the base b over to the exponent negative 1. So that's using the exponent property. So we have a 1 over b, we can rewrite that as b negative 1. The next thing that we're going to do is we're going to use the change of base formula. So using the change of base, we can go ahead and rewrite this as log of a over log of b to the negative 1. So then we have an exponent right here. We can again rewrite this using the power property, since that is an exponent. So So using the power property for the bottom here, or for the denominator, we can rewrite this as log of A over -1 times log of B. So this exponent becomes the coefficient of the whole log expression. So what are we going to do next is we are going to simplify this. So we can go ahead and rewrite this as -1 times log of A over log of B. So then we can go ahead and rewrite this some more. We use the change of base formula backwards. We can actually rewrite this as -1 log of A to the base B. So these two are equivalent. So then we can go ahead and simplify this some more. So -1 times the whole log expression right here is just the same as, that's gonna be negative log of A to the base B. So this is the equivalent equation for this one. That's a negative log of A to the base B. So this is our fifth property. Okay, at this time, I would encourage you to pause this video and evaluate this expression right here using this property. And if you're done, unpause it and check your answer. Okay, so we go over the problem here. So pretty much we can just go ahead and rewrite this as our, that's a negative log of, so we put in the value, our A is, the one inside the parentheses is 5, and then the B is 3. So I can go ahead and write 3 right here. So this is our, these two are equivalent equation. Now let's move on to the sixth property right here. So we have log of B to the power M to the base B to the exponent K. So what is this expression equivalent to? So from here, we can use the change of base formula. Okay, using the change of base formula, I can rewrite this as log of B to the power M over log of, that's gonna be B to the power K. So both of them would be, these two are equivalent. Now we are going to use the power property for this since we have an exponent. So using the power property, so power property states that whatever the exponent is, it's gonna become the coefficient. So I can go ahead and write M, so this becomes a coefficient, log of B, and that is over. This one right here is the exponent, so it becomes a coefficient, K log of B. So then we have log of B over log of B. We can cross these two out. This becomes 1. So then we have M over K. So then we go ahead and write this as M over K. So this is the sixth property. So I'm just gonna put this inside the box. So this is our sixth property right here. Now let's have this example right here. We're supposed to evaluate this. So looking at this, they both have a basis of 7. So what are we gonna do is we use the change of base formula. So I can rewrite this as log of 7 to the exponent 3 over log of 7 to the exponent 5. Now using the power property, the exponent becomes the coefficient of the whole log expression. So this comes out 3 log of 7 over 5 log of 7. Log of 7 over log of 7 gets crossed out. So then we are left with 3/5. So this expression right here is actually equal to 3/5. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!